All right, well, this is your introduction to stoichiometry. I'm guessing this introduction will come in a couple of different parts because stoichiometry is kind of a big deal and there's a lot of different things to go through. So I'll try to be watching the time here and break it into some different segments. Okay. So basically, we've kind of already been talking about stoichiometry. We've done some labs to show how things need to be balanced to get them to work out the best. So we've looked at how the chemical reaction is really just this recipe for how things combine, but it is a mole recipe. It tells us how things interact with each other in moles. The thing is, in lab, we don't measure out moles. We measure out grams or milliliters of a substance, and then we can use grams to turn into moles by way of the molar mass, or we can use milliliters to turn into moles by the way of molarity. Okay? So here's our roadmap. This is kind of what we're going to be doing. And if you compare it back to what we've already done in the moles unit, you should see some kind of commonality here. So this roadmap, you're always going to be starting with some quantity of some substance A, and you're going to be turning it into some quantity of some substance B. Now we could put off of moles. We originally had 4 different things. We had mass and volume, liquid volume, and gas volume, and particles. The particles really doesn't become important because in lab we're never counting out particles. The gas volume could be important, and we'll talk more about that in the next unit. But right now we're just going to be concerned with dealing with masses and volumes. So we're going to be using this roadmap and showing you, like, here's what we're going to be doing. So going from, like, let's take, for example, we're starting and we know the mass of one substance. So if you're starting with mass of A, you can go to moles of A using the molar mass and check. That's something we've had to do before. Once you have the moles of A, you can use the coefficient ratios from the formula, and this is basically the part that's really new, okay, for this, to go to moles of a different substance. So this way of relating the moles of one substance to another substance all comes from our chemical reaction. And then once we have moles of B, we could find something out about that we can measure in lab. And again, that's like, if we're going to get the mass of B, that's something we've done before, going from moles of one thing to mass of another thing. Okay, so we're going to kind of keep coming back to this roadmap because it helps to have a visual of what it is you're trying to do. Okay, so I'm going to start out with a non-chemistry reaction. And sorry, this got cut off a little bit. I set my screen size, I guess. Oops, didn't want that. So let me bring this in a little bit. Come on. I fumble around. And then there's some random characters there that we just get rid of. Okay. All right. So let's look at stoichiometry again. We've done lots of problems, but in terms of something that doesn't have anything to do with chemistry, they can maybe have an easier time picturing in your mind, and that is this question: how many pounds? Oops, forgot the how many. How many pounds of cars does it take to transport 9,000 pounds of people? So this is a pretty weird way of asking a question. Usually we wouldn't care how many pounds of cars, just how many cars we have. There could be some reason why we would ask a question this sort of way, but at least you can picture it. So the first thing I'm going to do is I'm going to draw like the roadmap in. So I'm starting with, I need to get to pounds. I'm starting with pounds of people. And from there, I would like to end up with pounds of cars. But I don't have a way that pounds of people are related directly to pounds of cars, because in my reaction talks about how many cars, how many people. Okay, it relates in that way. So I can't just go from pounds of people to pounds of cars directly. I have to go from pounds of people to the number of people. And then from the number of people, I have to go to the number of cars. And then from the number of cars, I can go to the pounds of cars. Okay, and so this was something we had to do too when you were working with like the s'mores example we did. Okay, where you had to go from the grams of like the chocolate to how many chocolate you had and everything else. And yes, I could have just told you that, but when then it would be like in chemistry, because we never count up how many atoms we have to start with in the lab. So to go from pounds of people to number of people, I'm going to take and then divide by the unit mass. Once I have the number of people to go to the number of cars, I'm going to multiply by the coefficient ratio. And then once I have the number of cars and I want to go to the pounds of cars, I'm going to multiply by the unit. And actually, these should be weights, not mass, because I said pounds. Okay, so I then solve. I start out with, well, I've got 9,000 pounds of people. And then it is one person is 150 pounds. Okay, so when I do that, I get that 60 people. If I take my 60 people and multiply by the fact that it's one car per 4 people, I'll find out I need 15 cars. And then if I take my 15 cars and I want to know then how many pounds of cars, it is 4,000 pounds per every one car. So I find out I need 60,000 pounds of car. Okay, so that's an example. This is exactly what we're going to be doing in stoichiometry, only we're going to be using not people and cars, but chemicals. So you've already had to work out this problem in class. Your first stoichiometry problem, looking at hydrogen and oxygen. You need to have a balanced reaction. So again, we can picture that, our balanced reaction. If I'm taking H2 and O2 to make H2O, I can't just take one H2 and one O2 because I only have one oxygen here, and I need 2, so I need to make 2 H2Os. All right, so I needed to start with 2 H2s in the first place. So this is a balanced reaction. Now I'm going to work out a problem just in moles. If I have 4 moles of hydrogen, okay, then what I need is 2 moles of oxygen to go with it because of this 2-to-1 ratio. And I'll make 4 moles of water because it's a 4-to-4 ratio with, or a 2-to-2 ratio, hydrogen and water. Okay? If it's 1 mole of hydrogen, I only need a half mole of oxygen. I'm going to make 1 mole of water. So again, this all works out nicely with that when you're dealing with moles. Okay, but again, the problem comes, what if we have, wonder why that did that. Okay, what if we have grams? So here's a, again, I'm going to skip this one, just in the interest of time. So boom, boom. Okay, you can work that one on your own. Okay, let's get to our first gram one. So we have a reaction here that is the reaction of methanol with oxygen to make carbon dioxide and water. And it says if you have 25 grams of methanol, that's the CH3OH, how many grams of oxygen will you need to completely react away? And how many grams of each product will you make? Okay, so the first thing I'm going to do is, whenever you're doing a stoichiometry problem, the very first thing you need to do is ask yourself, do I have a balanced reaction? So I'm just going to write that reaction out again here. And then I'm going to check it. Okay, so I have 1 carbon here, 1 carbon there. That's fine. All right, and I have 3 hydrogens plus 1 is 4 hydrogens total. And on this side, and on the other side, I only have 2. So I need to have 2 waters. Now, in terms of oxygens, okay, I've got 2 oxygens here with the water. I have 2 oxygens there, so that's total 4. So I would like to just be able to multiply this oxygen by 2. Problem is then I still got this other oxygen here. So the only way to get this to work out is to actually say I have 2 methanols to start out with, which means instead of 2 H2Os, I need 4 H2Os. Now I've got my 4 oxygens here plus another, whoops, gotta make that 2. So 4 oxygens here plus another 4 is 8. Take off the 2 that's already remaining, so I need to have 3 O2s. Okay? Now, I have a bunch of different questions here. I need to take my 25 grams of methanol and I need to turn that into, it asks me several questions. From here, it says, how many grams of oxygen do you need? It says, how many grams of each product will you produce? So grams, CO2, and then grams of H2O. So this is a pretty involved problem because it's asking for 3 different things. Okay? So that's more involved than most problems I'll have to deal with, but it will give us lots of practice. Okay? So I'm going to start with the fact I know the mass of something. So if I look at my roadmap, I know this here. Okay? Just looking at one problem, okay? Let's just look at this problem, grams O2. I want to get the mass of some B. All right? To get there, I need to go to moles of A, to go to moles of B, and then go to mass of B. So how do I do that? I start off with the fact that I've got 25 grams of CH3OH. Okay. Then I'm going to turn it into, so I wanted, right now I'm doing this conversion with the molar mass. So I want to get rid of grams. I want to go into moles. So I need to look up, well, what is the molar mass of CH3OH? So carbon is 12. There's 4 hydrogens, so that's 16 plus another oxygen. So it's a total of 32 and some change, and it works out to about 32.05. Whoops, putting that in the wrong place. So 32.05 grams is 1 mole. Okay? And then that gives me moles, so now I'm at moles of A. I want to go to moles of B now. So I don't want to be in CH3OH, so I put that on the bottom. What I want to do is let's find the grams, let's find O2. So I want to be in O2. Well, how do I know how many O2 is it per every CH3OH? I look back at the reaction. So when I look back at the reaction, 2 CH3OHs needs 3 O2s. So it's 3 O2s for every 2 CH3OHs. Okay? So then the next step, now I want to go, so now I've done this, now I'm at moles of B. Now I want to go to mass of B next. So I want to go here, and again I'm going to use the molar mass. So if I come back and check where I am in unit-wise, I've got grams, went away with grams. I've got CH3OH, goes away with CH3OH. Right now I am in moles of O2. I don't want to be in moles of O2, I want to be in grams of O2. So I want grams to come in, I want moles to go away of O2. So O2, if you look it up on the periodic table, each O is 16. So 2 O's is 32.00 grams for 1 mole. All right, so then I go and I just, now it's a matter of once I have it all set up, just plugging in the values. Okay, so 25 grams, 32.05, divide, so that gives me 0.78 moles. Now I'm going to multiply by 3 and divide by 2. That gives me 1.17 moles of O2. And finally, I'm going to multiply by 32 grams per mole and get 37 grams of O2. Okay, so that's answered one of my questions. I'm out of time for this video. Maybe we'll work the rest of these out in class. And I'm also probably going to continue on a little bit more, maybe with another video with just a couple more examples.